A very good evening to everyone. Today I'm going to do Digital System Presentation DGM 30073, the presentation about analog to digital system around us. So let me introduce myself. My name is Dhanushini and Parmasivan. My matrix number is 16DM21F1072. So what are analog to digital system? Let's see how does ADC works on. So there is an input analog signal. When it's go through analog to digital converter, it converts the analog signal to become digital signal. The output are digital signal. In electronics, an analog to digital converter (ADC) is a system that converts an analog signal, and ADC may also provide an isolated measurement such as an electronic device that converts an analog input voltage or current to a digital number, representing the magnitude of the voltage or current. Typically, the digital output is two complement binary number that is proportional to the input, but there are other possibilities. At the below, we can see the analog input go through ADC and we have digital outputs. So, what are analog to digital converters system around us? So, I choose to talk about digital microphone. So, we can see from this graph, the sound waves go through mic transistor, cartridge, element or capsule. These go through the analog to digital converter. So the ADC convert all these to the USB output power or connection. Microphone converts sound waves into AC electrical audio signal and are therefore analog device. However, some microphones like USB mics are designed with built-in analog to digital converters and output digital audio, making them digital microphone. We can see the sound waves, mechanical wave energy. So it goes to the microphone and the microphone acts as transducer and mic audio signal are present. Ideally, the first step in converting an analog sound waves into digital audio data is using a type of analog device called as transducer. So, as we know, microphones are transducer because they help change one type of energy into another through a special component called diaphragm. The diaphragm will begin vibrating respond to incoming sound waves, which creates an alternating electric current in the microphone. The AC voltage is its own analog signal, but one that can be passed through an ADC, which are analog to digital converter. So it's very fun because this ADC takes an analog signal that continues in both time and amplitude and translates it into a series of numbers that mostly accurately represent amplitude. So what is amplitude? You can see if the amplitude is very high, we can hear the sound very loud. If the amplitude is very loud, we can hear the sound very low at very specific point in time. It does this by the time taking a snapshot of the analog signal very often. So this snapshot we call as a sampling. So what are the sustainable aspects in context of environment or community? Let's see the sustainability of this digital microphone. First of all, I think so it produces sound pollution. All microphones have some self-noise, but it shouldn't be extremely noticeable unless you are listening very closely. If there is a buzzing noise, it usually a loose connection or faulty of the cable. If you try replacing the cable, but you are still listening some noise, but it can be the microphone damage. So sometimes you have to fix it. What you have to do, sometimes it can be the digital audio workstation that making the noise. So make sure to check connection your software isn't causing the problem. And then okay, let's see the other situation. If the sound is too loud, when you give a speech, we can adjust it. We can have a solution. We can adjust it through the lowering the frequency of the speaker. To avoid the sound pollution of the digital microphone, we can choose a condenser or active might be low self noise. We can use pop filter, use an RF filter, and use a balanced mic stable. If the mic is stable, I think so less sound is produced. Noise. So now let's see how does this system compare to ethics and professionalism. First, do not tap, blow into or hit the microphone, check whether it's working or not. Why we cannot hit the microphone whether the microphone is working or not? It can cause damage to the microphone. When you blow, I think so your saliva can be splashed onto the microphone. This causes the microphone to damage. Second, do not cover the mic as you hold it. Instead, do hold it halfway it's handled with care. Why you cannot cover the mic? When you cover the mic, I think so when you talk, the people cannot hear because the sound cannot be convert very well. The diaphragm cannot be vibrating your sound, so it cannot be amplified very loud. Third, do not touch the mic with your lip. Instead, do keep the mic pointed towards your mouth. Why we cannot touch mic with your lip? There's a possibility. It's unhygienic because there's a possibility your saliva can touch your mic and it's cause the microphone to damage more. Fourth, do not hold the mic on your chest. Instead, do keep constant mouth to mic distance about 6 to 12 inches. Why cannot mic very near? Because the people you can hear your sneezing, your coughing, your breathing. You know, it making very loud noise and noisiness. So you must keep like 6 to 12 inches. If you keep very far also, people cannot hear what are you going to talk because it's too far. So lastly, to give a better to make this digital microphone more better, as a technician, if I was a technician, to make this microphone more better, I would like to install the application of MEMS, Micro Electromechanical System. Technology to the microphones has led to the development of small microphones with very high performance. MEMS microphone offers high SNR, low power consumption. I think so this low power consumption is related to the sustainable of environment, and it is good because we can save energy. Good sensitivity and are available in very small packages that are full compatible with surface mount assembly process. MEMS microphone exhibit almost no change in performance after reverse soldering and have an excellent temperature characteristics. So that's all for me. Thank you for listening.